Welcome back to an intuitive introduction to probability. In today's lecture, I want to talk about an example of subjective probabilities. In my experience, whenever I introduce the concept of subjective probabilities, students early on feel a little insecure about what does it mean, subjective probabilities? How do I develop them? Can I just pick any numbers for subjective probabilities? Of course we can't. Your subjective probability cannot be 120% or minus 5%. That would violate the axioms of probability. Now let's look at an example where I would like you to develop your own subjective probability. Here's the description of a woman by the name of Linda. She's 31 years old, single, outspoken, very smart, majored in philosophy. When she was a student, she was deeply concerned with discrimination, social justice. She participated in anti-nuclear demonstrations. Now, I'm going to give you 8 options that describe Linda. And I now would like you to think about what do you think is most likely, second most likely, lowest probability. Of course, based on this description, your idea of Linda that you have in your head may be very different than the idea I have of Linda after reading this. And so now, based on this and your experience, your gut feeling, you need to develop some subjective probability. So what do you think? Do you think Linda is now a teacher in an elementary school? Or does she work in a bookstore and take yoga classes? Active in the feminist movement? Is she a psychiatric social worker? And so on and so on. When I give this question in class for my students to develop subjective probabilities, I ask them to give me numbers 1 through 8. Most likely a 1, least likely an 8. In this format I can't quite do this, so here now we do a little in-class, in-lecture quiz. I'm now going to offer you a couple solutions and pick the ranking that's closest to your subjective probability. It may not be exactly your subjective probability, but pick the one that you think is closest to your feelings. I hope you now filled out the in-class quiz and picked your favorite description. Here's now, I want to show you one answer that was among the options that you had that's very popular among my students. And that's the following. People usually rank, many do, very high that she's active in the feminist movement based on the description they got. That's usually something people rank very, very highly. Perhaps a 1, a 2 or 3. What I see with the vast majority of people who have to answer this question, they rank F, Linda as a bank teller, very, very low. So they say it's very unlikely that Linda now works for a bank based on the description. And the last option, Linda is a bank teller who's active in the feminist movement, usually gets sort of an average ranking. Now, let's think about whether this is really possible. Before we think about Linda, allow me to go back in an abstract fashion to 2 events, A and B. And here we have what's called a Venn diagram. There's a sample space, S, all the possible outcomes. There's a set on event A with some outcomes, B with some other outcomes, and A and B may have an intersection. We saw those an example of this sort in a previous lecture. Now notice the intersection of A and B. Remember from middle school math, those are the elements that are both in A and in B. This set A intersected B is smaller than A, and it's also smaller in B. It builds a subset of A and it builds a subset of B. What this means is that it has at most as many, usually fewer elements in it than A and B. And therefore the probability of the intersection must be smaller or equal than the probability of the individual events, P of A and P of B. Let me illustrate this again with a simple example of a fair die. Look at this picture here. A fair die has 6 possible outcomes. 1, 2, 3, 4, 5, 6. A are the even numbers, 2, 4, 6. B are the first four numbers, 1, 2, 3, 4. The 5 is neither an A and B, but it's an S. So that's outside the two circles representing the events, but it's still within S. Notice now the intersection. The elements that are both in A and in B. Those are the two numbers, 2 and 4. And here, look at this. The intersection probability of A intersected B is 2 out of 6. That's smaller equals 3 and 6 of A. And it's also smaller equal 4 and 6 of B. This is a general rule. So, if this is a general rule, your subjective probabilities must obey this rule. Now let's return to Linda. Look at C, F, and H. C is Linda is active in the feminist movement. F is Linda is a bank teller. H says Linda is a bank teller who is active in the feminist movement. Ah, look at H. That's C and F simultaneously. That's the intersection. What this means is that Linda is a bank teller who is active in the feminist movement must be ranked below bank teller and must be ranked below feminist movement. Of course, your personal opinion, maybe it's very likely that Linda is a bank teller. Maybe she sold out and she wanted to make a lot of money in later life. You can rank bank teller ahead of feminist, but no matter what you think, the intersection probability is going to be smaller or equal. So whatever your favorite ranking is, H must rank below F and it also must rank below C. So the subjective probabilities must have satisfy these two inequalities. I can tell you, I have given out hundreds and hundreds of times this questionnaire. Usually more than 80% of the students in a class get this wrong. So if you picked a wrong option before, you're in good and large company. This actually is an example of a famous fallacy, a famous way how we humans think incorrectly. It's called the conjunction fallacy. It was first documented in a series of experiments done by two famous psychologists, Amos Tversky and Daniel Kahneman. And here I give you a citation of a famous paper in psychology from 1983. Sadly, Amos Tversky died of cancer before he could have gotten the Nobel Prize, so Daniel Kahneman got the Nobel Prize in economics for his work, not on this fallacy and other fallacies as well, sometime later. This work is extremely influential in areas such as behavioral economics and behavioral finance. You may have heard about these fields that are now very popular, not only in academia, also in industry. And I encourage you to Google these terms, conjunction fallacy, behavioral economics, behavioral finance, to learn more about these fallacies, these mistakes that we make in decision making. To wrap up, two events occurring simultaneously cannot be more likely than the individual events by themselves. But often in our judgment calls we make that error. It has been well documented in many experiments. It's called the conjunction fallacy. So be careful with your subjective probability. It cannot be true that anything is possible. Obviously the probabilities are between 0 and 1, not 120%, not minus 5%. But in addition, there's also this intersection rule, the conjunction fallacy. So be careful when you develop your gut feeling and your subjective probabilities. Once again, thanks for your attention. I see you in the next lecture.